So let's find the following limits of these following three problems. And once again, we're going to be taking a look at the limit laws for e to the x and for ln x here. So you might want to pause and just write those down if you feel like you are going to need those. Otherwise, let's jump into our problems here. We are going to find the limit for positive and negative infinity for each one of these. So starting with f of x is equal to e to the 5x. I'm sorry, I wrote that wrong. E raised to the 5x. So we are looking at the limit as x approaches a positive infinity of e to the 5x. So that just means we're going to go down over here. The limit as x approaches a positive infinity of e raised to anything. The rule says that that is going to be a positive infinity. Now, if we find the limit as x approaches negative infinity of e to the 5x, well, going again back down to our rules here, the limit as x approaches negative infinity of e raised to something is going to be a 0. So that's just straightforward. Look at what you have here. It matches exactly up with the rule, so we can just state that answer. For the next example, we're going to find the limit of of 4 minus ln 3x. So let's find the limit. So let's find the limit as x approaches So let's find the limit as x approaches infinity of 4 minus ln 3x. Now we can rewrite this. This ln 3x is really 4 minus ln 3 plus ln x. Remember, this is multiplication, and you can break that up. A multiplication correlates to an addition in using your expanding rules of logs here. So we're going to take the ln 3x, we're expanding that to ln 3 plus ln x, right? And we have that 4 minus in front, making this 4 minus ln 3 minus ln x. And we are finding the limit as x approaches an infinity. Now, if x is going to approach infinity, that means this one here, ln 3, this is just going to give us a negative number. So we do know that that is going to be negative. Over here, we are taking a look at this one here. So if we find the limit as x approaches infinity of ln x, that is going to go to infinity as well. So we know that this is negative, large, it's approaching infinity. So the limit of this is going to be a negative infinity. Now for the next limit, we're going to find the limit as x approaches 0 from the positive side of the 4 minus ln 3x. So same thing, this can be rewritten as 4 minus ln 3 plus ln x, which just makes it 4 minus ln 3 minus ln x as x approaches 0 from the positive side. Now, if x is going to approach 0 from the positive side, you really want to think of that. So again, 0 from the positive side, you want to think of like 0.1. All right, so if we plug in a 0.1 there, what we're going to see here, this number is a constant. It's not going to make too much of a difference here. This negative ln 3, it's going to stay a negative number, right? If we do ln 3, that's just going to give us a decimal here. So we have this negative number from here, right? We know that's going to give us something negative. And then negative, or this is also going to be a negative here. And the limit of ln x is infinity. So we have a negative number and then a negative infinity there. So this negative along with this negative is actually going to turn that positive, and that limit is going to go to a positive infinity. Last example, the limit of cosine. So we are going to look at the limit of this cosine as it approaches a positive infinity. So the limit as x approaches positive infinity of cosine x, the limit as x approaches negative infinity of cosine x. Now, what we should hopefully remember about cosine is that cosine graph looks something like this, which means that we know that it's going to oscillate back and forth between a positive 1 and a negative 1. So as we go towards infinity, this is going to keep going up and down and up and down. So sometimes it's going to be 1, sometimes it's going to be negative 1, sometimes it's going to go somewhere in between, and it's just going to keep moving and moving and moving. Because it's never going to go to a direct point, it's always going to be changing. We say that the limit of that is not going to exist, right? Because the further we go, it's just going to continue oscillating. It's never going to stop. And we can actually say the same is true as the limit goes, the limit as x approaches negative infinity of cosine. Same reasoning. The further it goes to negative, it's going to keep oscillating back and forth, keep changing, which means it's never going to stay the same, which means the limit does not exist.